Hello friends, welcome back to AWS Developer course in Cloud Pedagogy. In next few sessions, we are going to work with an environment where we can begin with hands-on work in the developer tool suite. So in this introductory section, we will just take a look at DevOps basics and then we are going to learn about Git and GitHub before we proceed into code commit in this section. So we are going to start from the beginning. We are going to move rapidly and we are going to learn quickly and have fun while we are doing it. So how do we hone our DevOps skills? Well, we practice. We already set up our environment server while launching our student directory application. It's going to allow us as we go throughout the course to work hands-on with AWS. And from our terminal, we are going to issue commands to code commit. And then we work with code deploy, code pipeline, all throughout the developer tool suite. So we are just not trying to memorize terms here. We are going to work hard at this and get good at it by practicing as we go along. So with all that said, let's move on to our topic on thinking in DevOps. So this is Resh. She is a developer from our student directory application. Her job is to create new interesting features and write code. When Resh is done creating a new feature, she hands it over to Kins, who works in operations. Kins takes care of building and deploying that code, while Resh starts creating another new feature. However, sometimes bad things happen. One time, one of Resh's features that worked fine in her development environment brought up new errors and issues in the production environment. It was up to Kins once that code was deployed to solve these errors that were caused by the new changes. This wasn't very fun, Kins, as she was now managing this asset that she had no part in creating. And because she doesn't know it as intimately, it takes longer for her to troubleshoot it. It's not fun for Resh either, as she may feel like she is juggling this pending feature as well as the new feature she has to create. They both feel like there was a wall between their two teams. But ultimately, they both want the same thing. They want the code to be deployed with no issues. So how do the developers and operations teams work better together? Well, this very question is why DevOps is now so popular and why it's turned into a buzzword that's getting everyone's attention. But unfortunately, with all the press, DevOps gets confused with a lot of other technical concepts. For example, some think that DevOps is synonym with infrastructure as code, or the same thing as Agile, or just automated testing and delivery. But really, what is DevOps? DevOps is a way for the development teams and the operation teams to work better together, and ultimately they share the responsibility for the software they build. It is just a bridge over the gap between development and operations. And DevOps isn't any one of these technologies. It's really more of a cultural shift in thinking. For example, with Resh and Kins, they need to increase their collaboration, transparency, and their communication. They will also both be taking the responsibilities outside the scope of their current position. Resh taking responsibilities on the development side and Kins taking responsibilities on the operations side. As they work to bridge the gap, they will need clear expectations on both sides and to define who does what and how they will work together. All of that is cultural. That being said, the cultural shift in thinking is only half of the question. The other half is the tooling. This is where things like Agile and infrastructure as code and automated test and delivery come into play. The idea is that you take the application of engineering practices and tools and apply them to operations tasks. In turn, this should help you deliver applications and services faster and at a higher quality. There are a few key tools and practices that are becoming more and more common. The first is the idea of making things smaller. For example, a common practice is to perform very frequent but small updates to an application. This practice leads to significantly more deployments, with each deployment being less risky. That's because when things are small, it's easier to troubleshoot, identify issues, and in general, you have a smaller external impact. The second concept is to automate everything. This helps keep computing resources elastic and responsive to those frequent changes. And if you make a mistake, you can very quickly go back and reliably reproduce the previous state. And then the last one I will talk about is practicing continuous integration and continuous delivery. Often when you are moving very quickly, there are new operational issues you have to solve. It's true, you want to deploy quickly, but you also want to deploy in a safe and gradual manner. That's what CI/CD is all about, and we'll talk at length about this throughout the series of courses. Now, with the cultural shift side of things and the tooling you need to achieve DevOps, it's not just a one-time process that you set up at the beginning time and it will always work. No, it's not like that. It's a continuous practice, and to showcase this, technologists often use an infinity loop to represent all the steps of the life cycle and how they relate to one another. As you see here, what's needed for development is on the left side of the loop and what's needed for operations is on the right side of the loop. They are combined and you can't have one without the other. So how does DevOps work? Under a DevOps model, development and operations teams are no longer siloed. Sometimes these two teams are merged into a single team where the engineers work across the entire application lifecycle, like from development and test to deployment to operations, and they develop a range of skills not limited to a single function. In some DevOps model, quality assurance and security teams may also become more tightly integrated with development and operations and throughout the application of the lifecycle. When security is the focus of everyone's on the DevOps team, this is sometimes referred to as DevSecOps too. These teams use practices to automate processes that historically have been manual and slow. They use the technology stack and tooling which helps them operate and evolve applications quickly and reliably. These tools also help engineers independently accomplish tasks, like for example deploying code or provisioning infrastructure. There normally would have been required help from other teams, and this further increases a team's velocity. Next, we'll understand the benefits of DevOps. Speed. Move at high velocity so you can innovate for customers faster, adapt to changing markets better, and you can grow more efficient at driving business results. The DevOps model enables your developers and operation teams to achieve these results. For example, microservices and continuous delivery lets teams take ownership of services and then release updates to them quicker. Next, rapid delivery. Increase the frequency and pace of releases so you can innovate and improve your product faster. The quicker you release new features and fix bugs, the faster you can respond to your customers. And this accomplishes customers' needs and builds competitive advantage. Continuous integration and continuous delivery are practices that automate the software release process from build to deploy. Next, reliability. Ensure the quality of application updates and infrastructure changes so you can reliably deliver at a more rapid pace while maintaining a positive experience for end users. Use practices like continuous integration and continuous delivery to test that each change is functional and safe. Monitoring and logging practices help you stay informed of performance in real time. Next, scale. Operate and manage your infrastructure and development processes at scale. Automation and consistency help you manage complex or changing systems efficiently and with reduced risk. For example, infrastructure as code helps you manage your development, testing, and production environments in a repeatable and more efficient manner. Next, improved collaboration. Build more effective teams under a DevOps culture model. It emphasizes values such as ownership and accountability. Developers and operation teams collaborate closely, share many responsibilities, and combine their workflow. This reduces inefficiencies and saves time. For example, reduce handover periods between developers and operations, writing code that takes into account the environment in which it is run. Next, security. Move quickly while retaining control and preserving compliance. You can adopt a DevOps model without sacrificing security by using automated compliance policies, fine-grained controls, and configuration management techniques. For example, using infrastructure as code and policy as code, you can define and then track compliance at scale. Well, that's all for today's lesson. In the next class, we will talk about continuous integration and continuous delivery concepts. Hope it was interesting and helpful. See you again in my next video. Until then, take care.